All right, so we're going to go over the Go formative from yesterday. I'm not going to go over certain questions. So if you still do have questions, please let me know. For number 1 through 6, just make sure you know your vocabulary. Let's go on to number 7. The very first thing is I can see that we have the term isosceles. So I know right away that these two sides are equal. I'm going to then go in and label my sides. So I have 4x minus 1, x plus 5, and 7. Since I have an isosceles triangle and I want to solve for x, I know that these two sides with the tick marks are congruent, so I'm going to use them to make an equation. So I'm going to have 4x minus 1 equals x plus 5. And from there, I'll solve for x. In this demonstration, I will not solve all the way through, so if you do have questions with that, let me know. All right, then in the next set of problems, you have a congruency statement matching up letters in order. You can go back and check your answers in Go formative. It will let you know. I didn't get any responses on these questions, so I am going to skip over them. All right, the next two questions. Here we need to find x and y using our congruency statement. So the first thing I'm going to do is look for x, and I see x in angle F. So going to my congruency statement, not even looking at the diagram. Looking at F, I can see that it matches with B. It's both in the second position. So since B and F are congruent, so I'm going to write that. Angle B is congruent to angle F. I'm going to use a diagram to substitute that information in. So B is 135, and F is 10x plus 65. And then from that equation, I would solve and get x by itself. I'm going to repeat this process to solve for y. So y is at letter E, and the letter that corresponds to that is letter A. So I could say that A is congruent to angle E. And I'm going to create that equation again. So angle A is 28, and angle E is 4y minus 4. Again, you have to solve this equation to get your answer. This is just a setup. All right, moving on to our next question. Here we have our triangle. It's asking us to find the value of x. Remember, a triangle, the whole triangle is 180 degrees on the inside. So right away, I can see in my picture, I have a 90-degree angle here. So I have my three angles. I have 4x plus 5x plus 90 equal to 180. Then I would combine like terms and solve for x. Moving on to our next problem, we're actually going to repeat the same process. This triangle again, the entire triangle is 180 degrees. So I have 2x plus 3x plus 55 equals 180. I always make sure that I have my three angles there, so I know I have my three angles showing the sum of 180. And then we would combine like terms and solve again. All right, our next problem. A lot of us asked a question on this problem, and this is our remote exterior angle theorem. So this is where we need to know that our remote interior angles, so again, these two blue angles are our remote interior angle, and our green angle over here is the exterior angle. The relationship that you needed to figure out between the two was that when I add these two blue angles, they will equal the outside angle. So my equation should be 2x plus 76 equals 5x minus 2. And then we're going to get x on one side of our equation and solve. All right, going on to our next example. Here we're bringing back our isosceles triangle. Remember that these arrows point and remind us what angles are congruent. So both of these angles here should be 54. So x is already 54, no work required. In number 9, slide 9, sorry. Again, we have our isosceles triangle pointing. Here's those curve markings. So I know these base angles are both 10. Now I can create an equation. I could say x plus 70 equals 180. And then I would combine like terms and solve. Again, big takeaway is that tick marks pointing to the arrows, pointing to the angles. You have to make sure you're labeling all of it. It's more than just looking at the picture at this point. Slide 10 for me again. This is a repeat of the previous problem, so I'm not going to really show anything here. We have our base angles that you need to fill in, and then create your equation subtracting from 180 to find x. Next slide here, we have another isosceles triangle. Looking right at it, I can see I have these two curve markings. So again, remember that this is almost like a flashlight. That gets a tick mark on that side, and this side gets a tick mark. How would I solve for x? Well, since we have the two sides congruent, I'm going to put them equal to each other. So I have 5x minus 6 equals 3x plus 10. And then again, we combine our like terms, get x to one side, and solve. All right, next problem. Here we're bringing back our remote interior angles again. So here are the two remote interior. Here is the exterior angle. So now that we know our theorem, we can say that 55 plus 75 equals x. So we would simplify our left-hand side to get our sum, and that would be our value for x. Moving on to our next problem. Here we have an equilateral triangle. All three markings tell me all the angles are equal. So in this case, our triangle, the angle should be 16 each angle here. 180 divided by 3. Next problem here, we have a right isosceles triangle. So again, these are pointing like arrows. So I know that this is going to get a curve marking, and this is going to get a curve marking. So filling things in, I right away fill in an x, a 90, and then I'm going to create an equation. So x plus 90 equals the sum of a triangle, which again is 180 degrees. We would then simplify, combine like terms, and solve for x. Moving into the next slide, I just wanted to highlight a couple of things about marking our diagram. So if you actually put any markings on your diagram, for instance, if I mark this side in the middle, the shared side, and do not put any justification, I'm marking the problem incorrect. You have to tell me why you mark this. And here, the reason here is reflexive. And then I go in and check, are the two triangles congruent by SAS? So here is a side, an angle, a side, and then again, side, angle, side. So this is a yes for SAS. All right, going into the next example of the same material here, I cannot add any markings to this picture to help me get SAS. Here it spells out an angle, a side, an angle. So this is a no or not SAS. Next problem, here we can mark off our angles in the middle. Again, if you just mark this off and leave it, it's marked wrong. You have to justify. So this would be vertical or vertical angles. And then we check to see if SAS works. And in this case, it does. This is SAS. All right, moving into slide 18 for me. Here we're finding x and y. This is where you have to sketch a problem out like this and take it piece by piece, filling in as much as you know. So right away, I'm going to start where there's a number. The top triangle doesn't have anything. So I can see I have an isosceles triangle. So I have curve markings right here. So this is going to be 55. So now because I have 55, I can find this top angle right here. I'm going to put a dot there. I can find that angle by adding 55 and 55. And then I'm going to subtract from 180. And that's going to make this angle 70. Now, y is also going to be 70. I'm going to write that over here. So y equals 70. And the reason for that is vertical angles. So now in this triangle, we also have another isosceles triangle. So here again, pointing to 70 and 70. I'm going to add the 70s together, subtract from 180 to find x. So x is 40. So again, to repeat that process, I started down below where the number was given. I saw I had isosceles, I filled it in. Then again, we're using our triangle sum theorem. So I found that 70, pulled it into the next triangle by vertical angles, then used the relationship of isosceles again to get that other base angle. And then I subtracted again from our triangle sum theorem. All right, making our way to our last problem, where many of you ask questions here. So this is a triple isosceles problem. So the first triangle is I'm starting where the 37 is. So I can see that this base angle should be 37 as well. So now I'm going to find this angle right here. So I'm adding 37 and 37. And when I do, I get 74. I'm not done yet. I have to subtract from 180, making this angle 106. All right, so now I can move into the next triangle. Right here, I really hope you see that we have a linear pair. And I'm just labeling it for you guys so you can have that information. So how am I going to figure that out is I'm going to subtract from 106 from 180, making this angle right here 74. Now I'm going to pay attention to my tick mark. So the tick mark is pointing here, tick mark is pointing here. So I know that this base angle is 74 as well. So now I'm in this middle triangle. I can find this angle up here by adding 74 together. So 74 plus 74. Right, and that gives me 148. But I'm going to subtract from 180, and that gives me 32. So in this problem, y equals 32. And I'm almost done. Now I'm going to go into the next triangle, and I need to find x. Right here, and I'm going to kind of bubble it all in. These three angles are on a straight line. Remember, a straight line is 180 degrees. So I'm going to add up these two angles that I have and subtract from 180. So 37 plus 74 minus 180, making x 69 degrees. All right, I hope this helps. Let me know if you have any more questions.